Good afternoon, and welcome to today's T&D World webinar titled Not Your Grandparents' Grid, sponsored by Power Delivery Intelligence Initiative, also known as PDI Squared, and American Polywater. I'm Jeff Polsterwaite, Senior Editor of T&D World with Endeavor Business Media, and we'd love to have your participation in today's session. Of course, if you have any technical problems, just let us know in the questions window, and we will help you out with that. We recommend on your end, please disable any pop-up blocking software or Chrome extensions, things like that, as these can cause issues with the webinar player. And we welcome your questions. We want to have them. You can send those in using the question window at any time. You don't have to wait for the Q&A to begin. And please be aware that today's session is being recorded and will be available on the T&D World website in the next 24 hours. We will email you when the archive is available. It shouldn't take very long. And I'd like to introduce our discussion moderator, Mike Dealer, National Spokesperson for PDI Squared, the Power Delivery Intelligence Initiative. Welcome, Mike.
Thank you very much, Jeff. It's a pleasure to be here today with you to talk about your, it's not your grandparents' grid. So we're going to talk to Tom Fredericks today. Tom is the Vice President of American Polywater Corporation. Tom, are you with us?
Yes, I am, Mike. Happy to be here today.
All right. We're going to have a great conversation. Tom and I are going to talk about the grid and some of the challenges that engineers are facing in upgrading specifications and standards and some of the tools that are out there to accommodate that and some of the expectations of professional engineers today in the industry. Who is exactly the Power Delivery Intelligence Initiative? Let me just say that real briefly. It's a group of contractors and consultants and cable manufacturers and equipment vendors that advocate for underground versus overhead. When I say advocate, really we just want engineers, planners and engineers to take a look at the value of underground over the life of the asset. What is the total cost of the asset underground versus overhead? We think there's a lot of parameters today that need to be explored well beyond just the capital cost of overhead versus underground. So that's who the Power Delivery Intelligence Initiative is, and we do a series of webinars with our members over the course of the year. We have for the past couple of years, and we're real pleased to do one today with American Polywater. So Tom, let's jump right into it. I'll give you command of the deck here, and jump right into the first question is, why are we undergrounding? Why are we undergrounding so much? What are you seeing out there in the places that you travel?
Yeah, I think that's a great way to kick things off, Mike. And, please, we just want people to know that this is not going to be death by PowerPoint. There's just going to be a lot of discussion here. So be prepared to listen rather than look at the screen. Probably some of the main reasons right now that everybody tracks on the news is hurricanes. What they don't talk about much that hurricanes do and major storms like just happened down in Mississippi is the GDP impact from these storms. And the money lost during these storms, not to mention health and safety, is one of the biggest drivers of this. Another one is population shifts. So around the world, major cities are growing rapidly, and therefore the suburbs are growing too. And the population shift in the United States in particular is going to the outer perimeter. And this is causing all kinds of issues because people are moving from outside the major cities to get into the suburbs. And now wildfires are causing more issues, tornadoes, flooding, ice storms. A big one that's being pushed in California and other areas is the aesthetics, the pure aesthetics, that they don't want these overhead transmission lines or distribution lines in their viewpoints. Also, we see a major demand in electrification. In fact, on the slide there, you'll see that Princeton University has basically studied that this may increase by 50% due to electrical vehicles and battery operated power tools and what have you. So consumers, companies, government agencies, and utilities, due to these factors, the factors that cause outages, want improved resiliency. And underground is simply 12 times more reliable than overhead. It's safer for the crews and the public, and the cost to maintain underground versus overhead over the long haul is much less. We could also, Mike,
and actually, Tom, there's empirical data. There's empirical data, Tom, that does support that in the cost of maintaining overhead versus underground transmission and distribution lines. So your point on this is that there's a couple of drivers here. The need for resiliency as we see more and more of these big impactful storms that are causing a loss of gross domestic product in local communities, not the least of which is, places like Mississippi and certainly New Orleans. We've seen that in the last year or so. I think at Florida Power and Light, Tom, they say that if they're out of service for one day, out of service in the southern tip of Florida, with that service territory of about 5 million people, that cost the local economy $1 billion a day. So as planners and engineers start to take note of this, and then to your point, where we start to electrify more and more, engineers are definitely looking at underground. I would agree with you 100%.
Absolutely.
Are you hearing the same kind of thing? Yeah, go ahead.
Yeah, 100%. I was going to say, in one of our PDI squared meetings here recently, John Fluharty-Aquana basically told the group, because of some of the improvements that his utility made down in Florida of making the power lines taller than the trees during the last hurricane, his particular area had power throughout the duration. So there's kind of a real life occurrence there. I think we could also factor in labor shortage too, Mike, that if we take a look at the shortage of labor and we do strategic underground of utilities, the company would be in a better position in the long run.
Well, in the long run, I know there's men in the industry right now, men and women in the industry that are talking about that exact thing, that shortage of labor, in particular with vegetation management and tree trimming. Where are the tree trimmers of the future going to come if we've got to maintain these clearances to avoid outages, to maintain reliability, reasonable reliability, as we electrify more and more? And then the resilience, which is the ability to withstand a high impact but low probability event like a tornado or a wildfire. Where are we going to get these people, and how much is it going to cost to put, crews and equipment in the field to maintain these vegetation clearances? It's a big question. It goes away if you're able to underground the transmission line or the distribution line, and that's what I think, Tom, you and I are suggesting to young professional engineers and planners, is that you need to evaluate those kinds of equations when you're looking at a new asset, a new overhead or underground asset. You have to look at the total cost of the asset over the life of the asset. And of course, Polywater's got some tools that can help support engineers in that regard. What are you hearing from customers, though? You got a team of men and women out there in the field. Most major utilities are your customers these days, not only here in North America, but even you got customers all over the world. What are you hearing from your customers about underground in particular?
Yeah, and I appreciate that, Mike. Polywater specializes at the end user. The regional managers that are within the United States and Polywater's team of international sales force, we kind of start with the customers and the engineers. So what we're hearing worldwide right now is that many, many companies, utility companies, are really depending upon cable manufacturers and specialty cable installation contractors to help them with their projects, especially extra high voltage and transmission cable. But as you mentioned earlier, Mike, and what we're seeing because of the shift in population and rural growth around these cities, around the rings, we're seeing more and more companies that have begun undergrounding projects, and their companies are kind of faced with one issue, and that is primarily when that utility has been an overhead, let's say, specialist, and they always just had overhead, and now they're moving to underground. Who's going to engineer that project? And some of these overhead engineers are kind of tasked with learning that system, and it's completely different than overhead. And their crews also don't know that underground cables have different restrictions than some of the overhead cabling when they're doing tension cable. Here, when you install underground cable into conduit systems, they're subjected to ending tension requirements and sidewall pressure restrictions. So when you go from overhead stringing to underground, one of the big things that our company has experienced worldwide is the demand for our Pole Planner 4.0 tension calculation software. And that software, what is being requested of us is training on it, how to use it, kind of the tips and tricks of how you use the software to figure out how much ending tension and sidewall pressure and percentage of conduit fill or jamming, which will occur in these cases. So as people are building more underground systems and trying to pull longer distances, we do almost several trainings a day or presentations a day worldwide on this software. So this is absolutely skyrocketed.
I remember as a young engineer, Tom, that I always appreciated vendors that could come in and give me support and give me the tools and the research that I needed. I remember, I've been gone from Tucson Electric Power for over 35 years, but I remember the name of a salesman that would come in and make me successful in my job. I also remember when my boss told me, hey, I want you to learn substation engineering. I want you to be the project civil on this substation. I said, no, I don't want to do that. I want to be a transmission engineer. And he said, well, I'm not asking you. I'm telling you. And that's probably one of the best things that happened to me in my career as an engineer. So these overhead designers and engineers that design overhead, what a great opportunity now that we're doing so much undergrounding to be able to learn underground design as well. And so you're able to do both overhead lines and underground lines. It makes you more valuable to your company. And that's one of the things that companies like Polywater can help you learn to do. If you're not going to a class somewhere at some industry event, well, here comes the salesperson from Polywater, and they're able to help you with some software, which turns out to be very valuable.
Yeah, absolutely. And what I wanted to mention is, if I was to tell everybody online, what an example happened of a utility that had a robust underground system already in place, is that they started to use HDPE conduit, high density polyethylene. People may know it as roll pipe. But a contractor was doing the installation for them, and they got back to the engineer and said, we can't even pull 500 feet. Well, why was that? Well, we found out, through discussion and recommendation of talking to other industry peers that, when you dig a trench and you lay this conduit out, the conduit retains that real memory. And so the conduit, Mike, it actually looks like a snake within the trench. And they just let it be a snake, buried it, and now they had bend after bend after bend after bend, and that was affecting their cable pulling. So when we moved to undergrounding, and I believe you mentioned this before, and this is something that we're challenging everybody online, is to take a look at their practices, to take a look at their standards. And in this case, if you're going to be doing that methodology, it's best to lash each end of that conduit to get it straight so that you can pull farther over longer distances. So these guidelines of how the construction should be carried out need to be put in the plans or the specifications of engineers. And another thing that we would encourage people to do is start requiring that ending tensions are measured on these cable pulls. And why am I saying that, Mike? Well, we're working with an engineering firm right now in British Columbia, and they're working with a very large utility in that market. Now, one of the things that they did is they used our software to do some cable pulls, and they were showing the utility how they could actually save them money and pull longer distances. But the utility was a little leery of this. So this methodology of measuring and recording what the field tension is, and then using those values to back calculate what we call the field effective coefficient of friction to plan and design their cable pulls for the future to achieve longer distances, to eliminate splicing and reduce labor costs, is brilliant, because nobody can argue with what's happening in the field. So planning those pulls is closely followed by using the right amount of lubricant and the correct amount of lube. And we'll be discussing this back calculation later in our discussion.
I love that reverse engineering concept. We've talked about it before in the industry, but I think it's incumbent upon young engineers to it's an expectation of today's underground engineer to not just to assume or propose a coefficient of friction, but to actually go in the field, find out what the actual pulling tensions are, and then modify your assumed coefficient of friction to actual in situ coefficients of friction. And like you said, then get longer pulls, fewer manholes, more efficiency, built-in safety, better value for your company. These are all things that your company expects you to do as a design engineer. These tools are available. We say it's not your grandfather's or not your grandparents' grid anymore, because so many, Tom, and I know you can comment on this, so many specifications were written in the 50s and the 60s. And because we have this massive workload now of underground to do on some of these major programs that you're going to talk about here shortly, we don't have time to go back and rewrite the specification. Well, shame on us. We're almost 1/4 of the way through the 21st century. We cannot be using old specifications that were designed and written in the 50s and the 60s. We got to use new specifications, new standards that reflect today's emerging and emerging technologies and best practices. So yeah, we're getting lots of questions, Tom. I thank you. Thanks, audience, for the questions. We will get to these questions in about the last 20 minutes of this presentation, but these are some great questions, so keep them coming. We appreciate it. So did you want to comment a little bit, Tom, about some of the, I know we had a slide up that showed the logos of some of these companies that are doing strategic undergrounding, that are doing major underground programs. Do you want to comment on that a little bit?
Yeah, I mean, basically, I think people, when I joined, or I should say when Polywater joined PDI Squared, and we looked at, one of their main core principles is to promote and provide information on strategic undergrounding. And I kind of had the same misnomer that I think a lot of utilities have. Well, if I'm primarily an overhead utility, I can't afford to do 100% of undergrounding. And that is the misnomer here. You had mentioned this, Mike, and this is super important. There's a vast number of analytics utilities have recorded right now. They can identify where the fires occur most often, where wind affects an overhead line, where ice storms happen, and where the ice gets on the line. We talked about earlier about this build out and how homes are getting more in the rural area outside the city. And vegetation, obviously we talk about trees is causing the most issues. So if we look at that, we want to address these areas so that we can improve the reliability and or the resiliency of their entire system. So when we look at this, one of the ideas that I could just mention to the people online is a rural utility, their largest cost is what they call a truck roll. So if you can imagine a rural highway or a road where the distribution line follows, it's super easy for that truck to go to that area and work on the line. Where it becomes more problematic and costly, and where that utility can make a direct effect or influence on their system is that when the overhead line goes from that feeder of the distribution line to the house, that's typically where those trees are, and that's where the problem happens. So by undergrounding, and there are utilities in Missouri doing this right now in other areas that we're speaking to, is they're undergrounding from the pole to the house, and therefore they can reduce that. When we look at people that are members of PDI Squared, Burns and McDonald, they recently told us in a meeting that almost all of their customers are doing some sort of undergrounding due to these reasons.
Well, we know you mentioned Georgia Power. They're spending $3 billion over the next 3 years in doing undergrounding laterals. Florida Power and Light's going to spend $1 billion a year, ramping up in 2025 for 20 years to underground their laterals that they have not already undergrounded or hardened. Pacific Gas and Electric is going to spend $15 to $30 billion to rebuild their company, to quote the CEO, from the underground up. So there's a big initiative out there in underground, and we know that people. The very first question we got, Tom, was from a public power utility, and said, well, what about the cost of this? And again, the cost is the capital cost versus the operations and maintenance cost over the life of the asset. And that was a public power utility that asked that question. And there are some public power utilities out there, Tom, like Colorado Springs and Anaheim and Fort Collins and Beaches Energy. They have like 80 or even 90% of their systems are underground, and they are proving every single day in the value of underground. So I think we're making the point for underground. We're making the point that we need to look at the value of the asset over the life of the asset. Talk to me a little bit more about some of the cool things that you guys are doing to support these utilities, to help them pull longer distances, to help them have better standards and specifications, to give them the tools that they need to make these planners and engineers successful, make their companies successful, and even really, at the end of the day, to enhance the careers of these young men and women that are getting involved in these major programs.
Yeah, and I think one encouraging thing that we're seeing is that obviously Polywater is doing several things to assist these utilities, but the most influential or critical one is training people in on the software, which I had mentioned earlier. Now, the software isn't something that Polywater designed in the sense of the math. The math itself is based off the Riffenberg equations. So anybody that's online right now, if you go to cable manufacturers' installation guides, or you go into the syllabus or the addendum on the pull planner, you'll see the Riffenberg equations mentioned. And these are the only mathematical equations used to calculate how much ending tension and sidewall pressure you'll have on a cable pull. Now, the big difference is that back in the day, again, Mike, if we talk about using old data, outdated data, there was a group that did a study on coefficients of friction. And what that is the rub between the outside of the cable jacket and the conduit surface. So if you have a PVC jacketed cable on a PVC conduit, that is going to have one measurement of coefficient of friction. If it's a PVC jacketed cable and rigid steel conduit, that's going to have a different coefficient of friction, and so on and so forth. So the industry tends to use this number that's out there partly to be conservative when they're calculating cable pulls, but it's not necessarily real world. And the pull planner has a vast database on these coefficients of friction for numerous types of cable jackets and conduit surfaces. And by far, the coefficient of friction has the most influence besides the direction of pull on the actual cable pull. So the lower the coefficient of friction, the lower the ending tension and sidewall pressure you have. So the software then will be able to tell you which direction is better to pull, from A to B or B to A, and it's always better to pull through your bends first and then go down a long run versus the other way. So these tensions are very much enhanced by the experience and field experience that Polywater has harvested over the years.
Good, good. Do you want to talk a little bit about, you work a lot with the engineering community, the AEs, architectural engineers that serve a lot of the big utilities. Not all utilities are designing these systems internally. Sometimes they turn to consultants to get it done. What are you hearing from the engineering community? What do they say about their clients and their clients' use of technology and the way they're moving forward in underground or not?
Sure. I see we're skipping here, which is totally fine. So I think that's a great way to dovetail back into part two of my answer on the pole planner to educate people more. But the outside engineering firms that we work with on a regular basis that are assisting utilities and big industrial companies, is one of the things that they're saying is that they are restricted by some of these utilities to use what they currently have in their design or standards. And so if that utility, as you stated earlier, is working off an out-of-date or older standard or specification, these tend to be very conservative and in fact out of date. So this mentality of that's the way it was always done really limits building a better underground system. So all over North America and other parts of the world, especially developing nations where we're working with them on cable pulling, are kind of saying the same thing. And this is challenging for everyone because you've got two sides of this, right? And I call it the knowledge vacuum. And that's where the way I look at the knowledge vacuum is that you have a lot of industry veterans with decades of experience and knowledge that have retired during the pandemic. In fact, a lot of those people retired earlier than expected. And now with the newer engineers that don't have the experience, it's tough for them to take a chance rather than stay the course. But there are industry analytics, white papers, and studies available now to help design and update and create more robust systems to add strategic undergrounding or to make longer pulls to help their own companies have more resilient grids. But as you mentioned earlier, where do they have the time to seek these things out? And I think that's where companies like Polywater, cable manufacturers, and particularly these engineering firms that are assisting the companies really can help and shorten those gaps.
You know, one of the things about the AE firms is they do see what other clients are doing across the board, across the country, across North America, maybe in some cases even across the world. And so they see what others are doing. So if they engage with the client and maybe they go to the client and say, you know, these specifications are really old. This is not state of the art. I go to the IEEE meetings. I go to the CGRE meetings. I go to various industry meetings, and this is what I'm hearing. This is what I'm seeing. Here are the papers. Here's this industry support. And oh, by the way, I'm not asking you to take a risk. What I'm asking you to do is go out and field verify what the coefficient of friction really is, and then come back and reverse engineer how far could you have really pulled that cable if you had really had an accurate coefficient of friction. And I think those kinds of things are just going to be things that I think the next generation of young engineers, men and women, are going to do. I think that's just an expectation of what we as an industry should expect them to do.
Yeah, and I agree. And, you know, Polywater is celebrating 50 years in business this year. And so we kind of, as we like to say, live and die in this market. We're very focused on it. And we've got an incredible lab team that has multiple devices to test different cables and their jackets in particular on different conduit surfaces, and we can run hundreds of tests with those machines to provide those accurate coefficients of friction. So I think with companies, let's say, trying to achieve longer pulls, or they're new to undergrounding, or you've got newer people in the industry, we actually get cable and conduits samples shipped to us from all over the world, where our own lab does these testings. And that's why we can be even more accurate. So we've got companies that send us concrete conduit and Orangeburg duct and all kinds of things. And maybe the best way to explain, Mike, using that real data, is that everybody can understand miles per gallon. In cars today, you hit a button or go to a certain screen and it will tell you how many miles per gallon you get. I think everybody could agree if you drive into the wind versus downwind, you're going to have better miles per gallon, or going down a mountain versus up a mountain. And that's what the software does. It has a great feature that takes the ending tension off a cable pull, and it's called back calculation. It essentially tells you what your miles per gallon is, what your field effective coefficient of friction is, so that now you have that data and confidence to update your specifications.
We have hundreds of people online listening to us right now, Tom, and the last 10 questions have all been kind of technical. I think I'm going to take us in that direction a little bit and have you answer some technical questions, but I'm going to lead off with somebody that said something very nice about Pole Planner. It says, thanks for Pole Planner. And they name their utility, big investor owned up in the upper Midwest. We use it and we love it. So thank you for that comment. We appreciate that. So here's a question, and I'm going to go to these questions here just briefly because there's a lot of technical questions, and I don't know that we want to try to get into technically designing everybody's underground system, but there's so many of them that I think maybe we should address a couple. Do you have any case studies comparing end-of-life calcs on undergrounding versus overhead lines, given the present situation of having a more reliable grid system? And can we have copies? So are there comparisons? Let me take that, Tom. I think end-of-life comparisons, I would call up Dominion Energy and talk to Dominion, who's been doing strategic undergrounding for about 10 years now. And they are happy to share what they've learned at Dominion about the success and the reductions of O&M costs. I think they're coming up now with some real data over a period of time. And they can actually demonstrate that they've had some significant savings. They know how much their customers love the program. They know the cost to install these underground lines compared to when they're undergrounding the laterals. And so they're getting more and more data now over the last 10 years that really helps to address that issue. Here's a question, Tom. How many, and this is kind of philosophical, how many spare conduits should engineers consider when they do designs? You just want to take a jab at that? That's kind of a philosophical question about, number of conduits, any spare conduits. I think generally a conduit in the ground, once you put a conduit in the ground, it's an asset for the future. And 5-10 years down the road, it'd be nice to have that spare conduit in the ground for other things that might come up.
Absolutely.
Would you agree with that?
Yeah, I do. And then I also think there are some differences when you look at a city, underground in the streets versus, let's say, more distribution going in neighborhoods. One of the things that the cable manufacturers can do is they can help you plan on load. So one thing that the calculations do for you is you can take a look at what if situations, meaning if you're going to put in 3 500s today, and your city is going to scale up and you're going to need 750 or 1 million KC mill in those conduits, you could take a look at, if you wanted to reduce your costs, you could take a look at installing larger conduits or multiple conduits in those areas. And then maybe you want to look at DERs, how is that going to affect the grid? Do they need a place to go? So it's really kind of by design or demand, I think.
Well, your point about distributed energy resources coming and the demands on the grid is outstanding, and I think that's absolutely going to be a factor. So I actually do advocate. I'm thinking about writing a white paper on the very topic, frankly, of putting a few more ducks in the ground because we don't know what is coming up in the future. If you go to the maximum pulling tension, shouldn't consideration be given for the ability to remove the cable without lubrication? There must be taken into a consideration versus good pulling into the maximum calculated pull distance. So in other words, if you max out, this comes from a utility, if you max out on the pulling tension when the cable goes in, how does that impact you if you have to remove the cable?
Sure. Again, I think this dovetails into, one of the obstacles that people aren't aware of. Today, cables are built more robust when they did 20 years ago. The pulling equipment is more robust. People are using winch lines that can handle more tension and they don't surge like some ropes do. So when you install cables longer distances in their underground and conduit systems, we've worked with a lot of utilities, a huge one in Texas that had to remove all their cable out of Orangeburg pipe, which is kind of a fibrous conduit that swelled all around the jackets. And we were able to help them pull out all that cable using lubricant. So some of the techniques that we've been involved with and we hear is you can have a cable puller on one end, rodder equipment that are able to handle higher tensions to pull out that dead weight. So you're talking about a static coefficient of friction, meaning what does it take to get that cable to start moving? And you can, a good, let's say standard operating procedure is you can flood or pump in lube into that system and hook up a piece of equipment that can handle a higher tension than what you maxed out in. You can do what they call surging or thumping, where you kind of rock the cable to get it moving. Once it starts moving, you don't have that same tension that you did as you pulled in. So I don't think that this should restrict it. Worst case scenario, you can do what some, it happens at some utilities, it might be because of room, is you go to the vault or manhole that's midway, you cut the cable, you pull it out of there. If the cable cannot be used anymore and you're pulling it out, there are ways to get it out that aren't going to hamper your efforts.
Good. Tom, let's go back to some of the slides and some of the questions that we were talking about a little bit in this effort to have a conversation about underground and Polywater and some of the things that Polywater does and some of the industry groups that you're engaged in. So Polywater is involved in industry groups. There are certain industry meetings that you go to that you meet engineers, planners and engineers that are designing underground systems. What kinds of groups do you guys go to, and what kinds of practices are you engaged in, and how are you becoming more knowledgeable when you interface with these other engineers?
Yeah, I know several of my teammates are online, and they kind of make fun of me sometimes about my networking. But networking is a lost art, and one of the things that I would encourage everyone to do is to kind of take a look at some of these groups that I'm going to mention here. And one of the most powerful groups for underground cable is the IEEE ICC meeting. And that's the Insulated Cable and Conductor Committee. And I'll talk more about that in a second. If any of you are members of SEGRE like Polywater is, they just put out a huge paper on cable installation. And for the international audience on there, it might relate better to your region by having a SEGRE type of document. Polywater also is members of several groups that focus and are designed for the contractors doing this type of work, like the PCCA, Power and Communication Contractors Association. But local ones, Mike, that are in people's areas are the MEA, the Midwest Electrical Association, Western Underground, the Southeast Electrical Exchange, NWPPA, NEPA. These are just a fraction of the groups that are out there. All of these groups are focused on the power industry, and they've got leaders from the providers to the manufacturers to the engineering firms that attend these conferences and present the latest cutting edge and best practices. And when I was mentioning some of these earlier things about what we hear at the ICC, for example, especially for the newer engineer or people that are going to be doing more undergrounding, this group specializes on everything that touches a cable. The last ICC meeting in Denver this spring set a record. It was the largest number of participants ever. The attendees are getting younger. As like I mentioned before, the industry veterans are leaving. And that's why it's so important to attend and participate in groups like this to learn new things, be educated, but by far network. It's networking with your peers because you don't have to have the first rodeo. You can ask them about their network, like you were talking about Dominion and some of these other utilities that are doing tremendous amounts of undergrounding, and you can learn because they have data that they can share with you. And if I might get on my high horse for just a second, Mike, I want to mention two things. One, you can't find the information you're seeking for the challenges you have from the internet, but you can find it from these groups. So when you look at the C-suite, I really encourage the people online that are of management level, that are over these engineering departments, to not only support them going there, but they really need to understand the importance of investing in these engineering teams, because they really have a direct influence on how the company performs. That's what I would say.
I agree. And your comment about the ICC having record attendance this last spring is really interesting. You think about all the things that are going on, these major strategic undergrounding programs that are converting the overhead laterals to underground across in many, many parts of the country. It used to be in the southeast, but now it's spreading all over the country. You think about all the new expansion as southwestern and southeastern cities grow. And with that growth, most of that new growth goes in underground. It's just the way it is. And then you think about the major transmission lines that are going in. Some of those are HVDC underground and submarine cables. Big projects that are going in. We're looking at the use of transportation right-of-ways, whether it's rail right-of-way or whether it's interstate highway right-of-way. That's going to go underground. And then you look at offshore wind as well. And so there'll be these undersea cables that will have big underground landfalls, basically, where they take the undersea submarine cable and then they bring it up underground onto land into the substation. So it's no wonder that ICC has got record attendance, because there's a lot going on in the industry. A lot of it is underground, and young engineers in this industry need to get the state of the art. They need to find out what the emerging technologies are and what the best practices are. So great news. You like Southeast Electric Exchange, Northwest Public Power Association, Western Underground, some other organizations like that, Tom?
Yeah, we participate with all of them, and it's just I would say that when you go to these conferences, it's different than a trade show. A trade show, people kind of walk around, it's busy, you can't have kind of side or meaningful conversations. What I really like about these groups and these conferences is everybody's there for one reason. They're there to learn. And so there's a different mindset that happens when you're at the ICC or NEPA or NWPPA. They really are regional, so they're all experience kind of the same challenges or opportunities, and that's why they're so powerful. I think just everybody is just really open to these ideas, and they just get so much value from being able to talk to the industry experts and their peers. Yeah. Well, that's good. So that would probably be your recommendation, and to go to your boss and say, hey, I need to go to a couple of these. ICC meets twice a year, right? I need to go to both of the ICC meetings and maybe one or another. I know in 2024, Tom, I happen to be a big fan of Distributech
That's coming up in 2024, I believe, in Orlando in February. Then next year, the big IEEE Power and Energy Society Expo is coming up in Anaheim in May of 2024. That's another really big industry show. That is a show. There will be vendors on the floor. There'll be 1,000 vendors on the floor. American Poly Water will probably be one of them. But there's a lot of technical presentations there as well.
Yes.
Okay. Do you want to make any other comments before we go to these questions about generic performance specifications? We talked a little bit about that, generic specifications that maybe were designed in decades past. And you see us moving forward? You think we're making progress as an industry and moving forward on that or not?
Some. It's and I'll keep this short because I think you've got more questions piled up for us. But let me just kind of give you an example of what we see. So engineers have the best intention that they know that because of the weather patterns now, superstorms, whatever their challenge is, they will have an example of a spec will be all conduits shall be sealed. And then secondarily, they'll say seal around the conduits when they're going through a concrete wall. The problem with both of those is that they're not specific enough and they're not performance-based. So if I shove a T-shirt in the end of the conduit, or in this instance on the left, this product is called duck putty, and duck putty was used by HVAC people until they invented duct tape, but the electricians work side by side. We see a lot of substations use this product. But it's made of clay, it dries, it sags, it doesn't hold waterhead pressure, there's no cable compatibility, there's absolutely nothing. So if you're going to make a spec, you need to think about what are you trying to stop? What is the NEC code? What is the NESC code that I could use? And how can we make it performance-based so that whatever is put into that conduit is compatible with all parts of the wire and it's going to hold lots of waterhead pressure, like Polywater's both chemical, a two-part foam that's closed cell, and then our mechanical seals. Same thing goes for around the pipe, around the conduit. When it enters a concrete wall, typically people will use mortar, but mortar now, you've got to wear special masks. It needs an accurate mixture of water. It's got to be troweled in expertly, otherwise it's going to leak. Or they just go to the hardware store and get some cheap can of foam. Neither one holds waterhead pressure. They weren't intended, to seal around that. And we make, and there are mechanical seals that do a much better job. So the challenge for everybody online or when you're talking to your customer is to take a look at your current specifications and standards and see how you can improve them. Because if you can make them more resilient, it's going to pay off in the long run.
Yeah, that's a great point. So let's go to some questions here. We've got about another 10 minutes to go, and we got some great questions from a variety of people. So here's an interesting question. Do some cables have easier pulling properties? Are they easier to pull than others? So what are your thoughts about cables and the cable pulling properties of a given cable from like a particular cable manufacturer? Yep,
so that is an awesome question. All right, so remember I told you that the industry standard, they use 0.35 coefficient of friction. That's their multiplier. But they use that 0.35 no matter what kind of cable you're pulling in, meaning the jacket, is it PVC, is it cross-linked polyethylene, is it low-density polyethylene, and whatever conduit you're pulling into. There is no one coefficient of friction. So for example, let's say you've got a conduit that's got a lot of water in it, or it's an older conduit system. Again, I'm trying not to be, I'm going to be somewhat Switzerland and somewhat Polywater here. If you use Polywater lubricant, again, in the tables, we can tell you when you're pulling in a, let's say, cross-linked polyethylene cable jacket in an HDPE conduit, we'll actually tell you which one of our lubricants is a better performer in that system. And if you're pulling through water, which one is going to perform better through, pulling through water. which is going to help you. And by far, as I mentioned previously, let's say that your utility does a lot of directional boring where you've got some wiggles, but it's hard to tell where they are. Or you have an existing conduit system that, even though you used a good pulling practice where you mandreled or brushed out the conduits, you still got mud and some dirt in there. By again, measuring and requiring people to record the ending tension, that is when the cable exits, that head end of the cable exits the end of the conduit system, is to look down on the tensionometer, dynamometer, write that down and back calculate it. And by far, that is going to be the best tool for you to help pull longer. So you can look at our tables and you can kind of see, what matchup might work best, but the lubricant is the biggest influencer on that.
And I'd comment too, if I'm doing an EPC project where somebody's going to engineer, procure, and construct a cable system for me, part of my specification is for that contractor to record that coefficient of friction, that cable pulling tension, so that I've got that for my future use. So here's another question, Tom. Is there a big difference between installing 3 cables in a conduit versus a single individual cable in a conduit?
Yes, that's another good question. So sometimes people believe that oversizing their conduit makes their cable pull easier. So again, you can look up jamming ratio online right now, which is big D divided by little d, or you can have our software do it for you. But when you oversize conduit and your cables become cradled, so all 3 cables now are laying side by side in the bottom versus triangular where they're stacked, you have more rub. When they're triangular, you only have 2 places of rub. But the biggest one to factor in is that if you have bends and 90s in your system, and let's say you do short radius bends, it's not a problem because you can figure it out. So this is super overcomable in the field. But by doing that calculation, it will tell you how much jamming that could occur. So when your cables are cradled, it will tell you whether there's no problem or if jamming might occur. And it usually happens through short radius bends, not long sweeping bends. Otherwise, they're really, when it comes to cable pulling, if you're using good cable pulling equipment and you've planned the pull, there's really no difference that you can't overcome by pulling one single conductor in a conduit versus multiple conductors. It happens every single day.
Okay, so can the Pull Planner 4.0 do that? Can they calculate maximum pulling of multiple cables, the pulling tension for multiple cables? Does the software allow that?
Yeah, so it will calculate the ending tension regardless of, I know we have some industrials online and they have control cables. It doesn't matter if you have 12 cables, three cables and a ground or a neutral, or 1 cable. The software will calculate the tension that could occur on the pull, what the sidewall pressure is going to be on the pull, and incidentally, it's the sidewall pressure that gets people into trouble more so than the ending tension on the cables. And all cable manufacturers, their sidewall pressures will differ based on the makeup of their cable, how they're built. But it will also tell you what the percentage of jamming that could occur, and that you can only do on 3 cables. That's the way the math works. If you've got 1 cable, it's pretty easy to figure out. If you're pulling a 5-inch cable into a 4-inch conduit, you can't do it. But the software does all of that, and we have an excellent relationship with all the cable manufacturers. These manufacturers of cable are just outstanding.
Well, I think that's going to segue into the last question that comes from the audience here. And it says, can you please give your recommendation about how much % of a maximum tension and sidewall pressure should an installer use? So you've got the software, but you have some ideas of what the maximum sidewall pressure would be and maybe the maximum pulling tension on a particular cable might be. Does it vary from cable to cable, from conduit to conduit? Yeah,
and again, another excellent question. So when you come to sidewall pressures, and if you need names at, companies out there, whether it's Okanite, Prysmian, Southwire, NTC, Tyhan, LS, whoever it is, we can give you help with their application engineers. But on their spec sheet, you need to pay close attention of if you're buying a 500 kc mil cable from X manufacturer and Y manufacturer, because the cable construction is different. And so the sidewall pressures will be different, and they will tell you what the durator is, meaning they will tell you what you can achieve. So they might say you can go to 80% or 90% of that sidewall pulling force. So you really need to get that from the manufacturer. When it comes to ending tension, whether it's soft copper, hard copper, aluminum, the industry at one time, and I know things are rapidly changing, so I don't want this as gospel, but at that time, they believed the conductor, regardless of whose it was, they all agreed on what that maximum allowable tension is. But I would really go back to your manufacturer and they will give it to you. Now, the nice thing is that if you use the software, and by the way, I should tell everybody online right now that if you want a free copy, absolutely free, no strings attached, you can get a free copy of our software. Just send me an email and we'll give you the download instructions, the password. You can have it that easily. But in the software...
Ironically, Tom, that was the last question that just popped up.
Oh.
So thank you for mentioning that.
Okay. I'm psychic today.
Yeah.
But in the software, the great thing is that before you even start calculating your pull, even if it's 20 segments long, you can enter in the maximum sidewall pressure allowed and the maximum allowable tension. So that way you can see when you pull from A to B, you might exceed it, but pulling B to A, you might not. Or when you get to segment 7, that might be where you exceed it. So the software, you can put it in just basically a la carte, depending on whichever cable manufacturer you're using, so that you don't have to go back to the tables. You can put it in there and that can help your pulls.
Yeah. Great information. Really appreciate that. Tom, give us a few concluding remarks here. Maybe you want to say one more thing about the pull planner and some of the goals that you think that we as an industry ought to have for specifications when we are not building, a grid based on specs from the 50s and 60s. Any concluding remarks today?
I guess I would just encourage people. Brave is probably a strong word, but doing the same old is not going to advance your system. So I would really challenge people to take a look at the current specs and standards, because cables, pulling equipment, contractors are all and have made changes to their systems to achieve longer, better cable pulls to help you. And the pull planner can help you do that, and it's free. But that's what I would say. Take a look at those specs and standards and join and participate with these industry groups. They just do nothing but good for you and your team. Yeah, well said. Appreciate that American Polywater is part of the Power Delivery Intelligence Initiative. We are advocating that we look at the total cost of ownership of the life of an overhead versus underground asset. So on behalf of Tom Fredericks from American Polywater and on behalf of the Power Delivery Intelligence Initiative, thank you for listening today. We appreciate it. And Jeff at T&D World Magazine, back to you.
Thanks, everyone. That is all the time we have for today. For questions that we didn't have time to answer, we will be getting back to you via email. And so on behalf of T&D World, I'd like to thank the Power Delivery Intelligence Initiative and Polywater for bringing today's webinar to you, and of course, all of you for joining. Thank you very much. Have a great rest of your day.